In this video, we're going to go through something called measurement scales and evaluating what are called the different levels of measurement. So when we talk about the levels of measurement or the level of data, depending upon the type of data, that would dictate the particular statistical procedure to carry forward with. Now, when we take a look at these four different levels of data, the one question that comes up is one level more valuable than the other? And the answer to that question is not necessarily. The value of data is dictated by the research design and the research question. Some data, some information that's gathered just naturally fits into one level or another. And so the numbers, regardless of the level of data, represents something to be measured. And in this figure here, what we see are the four levels of the data, ranging from what is referred to often as the lowest level of data measurement, but I think more precisely to state, it's the simplest level of data, and that's the nominal scale, and we'll discuss that here in this video. The next level up is the ordinal scale, followed by the interval scale, and the highest level, or according to the figure, is the ratio scale, which I think more precisely stated represents more complex level of data. And so we begin with the simplest form of the data, and that's the nominal scale. Now, the nominal scale occurs when we apply numerical values to identification scores. And so we're not actually measuring our number doesn't measure an actual amount or quantity or any inherent value. It just identifies different categories, but we use a numerical value to identify different categories. And the key variable on a nominal scale is to count the number of occurrences in each category. And so this approach will classify groups or classify particular responses, and there's no particular order or no particular value assigned to each of these groups or responses. So some examples here is if we ask a group of individuals, a group of people, if they feel professional athletes make too much money. So the question posed would be, do professional athletes make too much money? And the person, the research participant, would answer with a simple yes or no. That is a nominal scale, and we would count up how many yeses and how many nos. If we want to count how many students are enrolled in different academic departments such as psychology, biology, history, management, business. Once again here we're looking at a nominal scale, and we're just counting the number of occurrences within each of these different categories. Sex at birth can be classified as male or female, and in this case these are two categories. Note that this would also be a dichotomous variable if we only define it as two. A second definition of sex at birth is variant, which would be female, intersex, or male. This would be three categories. Now, this would not be dichotomous. Remember, dichotomous die for two, depending upon how we define it. Gender, on the other hand, can be defined as man, non-binary person, or woman with respect to adults. And the category that we pick here should be defined per accepted an accepted mean. And so these latter three bullets items, sex at birth variant, and gender, are the definitions adopted by the federal government under Statistics Canada. So it must be clearly defined as to what the category is represents from a research perspective. And to fit a nominal scale, there are three criteria. One, it must be mutually exclusive, in that there must be one and only one category for each case. So if we take a look at professional athletes making too much money, one person cannot answer yes and no at the same time. There must be that clear separation, so they're mutually exclusive in that case. It must be exhaustive, in that a category has to exist for every possible score that might be found. So this will put it on the discrete level. So there's a very finite number of categories. We don't have an infinite number of categories. So in our examples, our latter three bullet items, we have 2 categories, 3 categories, 3 categories for gender. So it must be exhaustive in that case, and each category should be homogeneous, in that within each of the 3 categories, if we look at gender or sex at birth variant, the cases or the individuals within each of those 3 categories should be comparable, making those homogeneous. The next scale up from the bottom is the ordinal scale. So the ordinal scale is very similar to the nominal scale, in that the ordinal scale has a natural order of progression to the elements inside a particular category or between categories. Now in this case, the scores only indicate a position between the items and not necessarily an actual amount or an actual quantity. Some examples of an ordinal scale might be income level. So from a research perspective, we might define income level as low, middle, high, or very high if we adopt that definition. And because there's a natural order that's defined in terms of a monetary range, this would be an example of an ordinal scale. If we want to measure personality traits, one personality trait referred to as extroversion can be measured from low to high. So this is according to an accepted definition of extroversion. Some opinion surveys range from agree, strongly agree, all through the scale to disagree or strongly disagree, could be construed as an ordinal scale. If we're ranking various mutual funds by risk, low risk to high risk mutual funds, then as long as there's that natural order, it would be considered an ordinal scale. One other example, that's what you see in the picture here, is a clinical measurement of muscle strength. And in this example here we have an athlete or a patient being evaluated by a physiotherapist, and the physiotherapist is making a subjective assessment of muscle strength in the event of in a suspected knee injury. And the therapist would use a predefined ordinal scale of the grading that muscle strength from a value of 5 all the way down to 0, and as you can see here, there is a clear definition for each of these values. So based on so for one patient, the physiotherapist might assign that a value of 3, which the person has complete range of motion against gravity with no resistance. So the major point here is that we have a natural order that ranges from 0, in which the patient cannot contract their muscle, up to the highest level of 5, where they have full range of motion and full resistance. The next scale up from the ordinal scale is the interval scale, and when we move into the interval scale, we're actually describing an actual amount, an actual quantity. So these numerical values are used to now quantify how much of an observation exists. And with the interval scale, it's named according to the fact that there is an equal interval between that separates the scores. The interval scale is unique in that it can have negative numbers, and there's no true zero. Rather, zero serves as a reference point for the other values. The classic example is temperature in Celsius or Fahrenheit. Another example is financial status. And so Celsius or Fahrenheit, depending upon the scale we use, are the units of measurement. Financial status, dollars, is used as the unit of measure. And so in this example, temperature and financial status are considered the variables. Each variable on an interval scale should have a unit. So for temperature, the unit would be Celsius or Fahrenheit, and dollars is the unit for financial status. And so can temperature take on a negative value? And yes, it can, where 0 represents a reference point for positive or negative temperature values in Celsius or Fahrenheit. Can dollars take on a negative value? And if we're talking about financial status, a negative balance would indicate a running deficit. A positive value would indicate a surplus, and 0 would indicate a reference point between those two definitions. The highest scale is referred to, one scale up from interval, is the ratio scale. And much like the interval scale, the ratio scale also represents the amount of the variable that is present, but the amount is scaled to a true 0. So the major difference between a ratio scale and an interval scale is the reference of the 0. And in the ratio scale, the 0 actually represents the absence of the quantity measured. If we take a look at 0 degrees Celsius, it doesn't mean that there's an absence of temperature. It's just a reference point for either warmer temperatures above 0 or colder temperatures below 0. But 0 still has a temperature. For the ratio scale, the value of 0 for employee payment, where the unit would be dollars, would indicate that the employee did not receive any payment, so $0. In terms of age, an age of 0 would indicate the start point of a person's natural age after birth, where 0 represents no age until birth happens. But because interval scales and ratio scales are often carry the same units, these two scales often overlap in terms of identification. So it's one key way to remember that is the role of the 0 value, where in the ratio it represents the actual absence. The interval scale, it represents a reference point and not the absence of what is being measured. So this ends this lecture on our introduction to statistics.